Hello everyone, my name is Mario Tiozzo and I'm the Data Analysis and Visualization Librarian here at UMB Libraries. Today we're going to go over a basic overview of Microsoft Excel. Excel can be a very complex and intricate software program, but here we will scratch the surface and get you going and hopefully set you up for future exploration of what Excel can do for you. First things first, let's take a look at the Microsoft Excel environment so that we all have a common language and understanding of what is what. When we first start Excel, the first thing we see is a screen that allows us to create a new file or open an existing file. Excel will also list recent files that you have opened or ones that you have decided to pin. We'll open a new file for now and click on a blank workbook. As you can see here, Excel is a spreadsheet program, which means that it is effectively a grid composed of a series of columns and rows. Each column is named alphabetically, A, B, C, and so on. An entire column or columns can be selected by pressing on the column headers. Each row is named numerically 1, 2, 3, and so on. An entire row or rows can be selected by pressing on the row header. At the intersection of each row and column lies a cell. Every cell has an alphanumeric name. So cell A1 would be at the intersection of column A and row 1. So the top left cell of the spreadsheet. There is always one and only one active cell in a worksheet. Right now, that cell is C5, which you can see as it is highlighted in green with a white background and appears in the active cell name area. While there can be only one active cell, it is possible to highlight and modify a collection of cells called a cell range. A cell range is defined by its upper value, followed by a colon, and then its lower value. Here we have a vertical cell range that begins at C5, the active cell, and ends at C14. We can identify this range as C5, C14. Cell ranges can be vertical, like the one we just went over, horizontal, such as this, C5 to G5, or rectangular, C5 to H14. At the top of the worksheet, you will see a series of tabs, such as File, Home, and Insert. Yours may or may not have all the same components as mine, but the concept here is the same across all Excel packages. Clicking on the tab will reveal its associated ribbon, which includes the relevant command buttons grouped according to related functions. For example, in the Home tab, the Paste command button is grouped together with the Cut command button, the Copy command button, and the Format Painter command button. At the bottom of the worksheet, you will see a tab with a worksheet name. The default name of the worksheet is Sheet 1. You can add a worksheet by pressing the small plus icon next to the Worksheet tab. You can delete a worksheet by right-clicking on it and choosing the Delete on the menu. You can rename a worksheet by right-clicking on it and choosing Rename, or by simply double-clicking it and typing in a new name. The collection of worksheets in a file is called a workbook. In fact, a workbook is just a fancy name for an Excel file. In our example here, our workbook is called Book 1, which is the default name. Okay. That's a decent place to zoom back in and figure out what you can actually do in Excel. Back to the individual cell. Each cell has a capacity to store a formula or a value, such as a static number, or a string, typically a static word. While we'll go into formulas in greater depth in a few minutes, let's quickly take a look at how to perform basic mathematical operations in Excel. Here we see the results of fictional experiments. If we wanted to add the scores of the first 3 experiments, we could go to any empty cell, for example here, which is D15. We would press the equal sign. A formula or a calculation always starts with an equal sign in Excel. Then we could type in the coordinates of each cell. Remember that all cells are alphanumeric, so it would be D5, you can see it's highlighted, plus D6, plus D7. We would press Enter, and the result of the operation would appear, 133. Alternatively, you could also write the equal signs and click on the cells that you wanted. So click on D5, add the plus sign, click on D6, add the plus sign, and click on D7, and press enter. Same result. By putting the active cell on the cell with the results, you'll see the formula you wrote in the formula bar. If it's a static number, such as here, or a string, you'll see that in the formula bar. If it's a formula, however, you won't see the result, but rather the actual formula that created that result. You can also double-click on the results cell, and it will show the formula with the colored highlights. Now, if you click on the formula bar, the coordinates will match the colored highlights. So we added up a few cells by using the plus sign, but we can also use other operators to perform mathematical calculations. We can use the minus sign to subtract cells or to create a negative number, the asterisk to multiply cells, the forward slash to divide cells, and a caret sign to use as an exponent. So these operators can work well if you have a small data set. But what if you had hundreds or even thousands of entries? Clicking each cell would be very time consuming. And what if you wanted to do something a little fancier than just basic arithmetic? That's where formulas come in. There are a lot of formulas. Some are simple and others are more complex. You can also nest formulas, which means creating a formula containing a bunch of formulas within it. But here we'll take a look at some basic Excel formulas that all have the same structure. As with all Excel formulas, they all start with an equal sign. The equal sign is followed by the name of the formula, which we'll go over shortly. Please note that although the function name is in capital letters, formula text is case insensitive. Excel will automatically reformat the text in capital letters. Next step is the cell range of cells, or multiple cell ranges, which are encapsulated by parentheses. Again, this entry is also case insensitive. So that's the basic outline. Let's take a look at a few functions. First, let's delete this. Okay, here we go. The sum function calculates the addition of a range or ranges of cells. In our example, to calculate the sum or total of all the cells in the range, we would find an empty cell and type in our formula. So remember, equal sign, followed by the name of the formula, which is sum. You can see that it auto-populates. We'll use the first option. Open parentheses. This lets Excel know that we're ready to ingest the data. Then we just highlight, in this case, the cell range that we're interested in calculating. Close a parentheses and press enter. The cell now produces the answer, which is 345. Maybe we'll just put a little tag here to let people know what this is all about. So this would be the total. The count function calculates the number of numeric values within a range or ranges of cells. In our example, to calculate the count of all the cells in the range, we would find an empty cell and type in the formula. Again, equal sign, the name of the formula, which is count. Again, there's a whole bunch of different options, but we'll take the first one. Open the parentheses. It tells you what it wants you to ingest. See, it says value, value 2, etc., etc. We'll just do a cell range here, and then we'll close a parentheses, press enter. That makes a lot of sense. There are 10 experiments, and the count is 10. Here we'll put number of observations. Note that doing a count on the string side would produce a 0 result. Why is that? Remember, the count function only counts numerical data. Since this is a string, it doesn't find any numerical data. If we wanted to count the strings, we would have to slightly alter our formula to a count A formula, which then counts all non-blank values. This returns 10. Okay, we'll delete that for now. The average function calculates the average of a range or ranges of cells. And by average, I mean the mean. If we wanted to calculate the median or the mode, we would need another formula for that. In our example, to calculate the average of all the cells in a range, we would find an empty cell. Let's pick this one, D19, and type in our formula. So again, equal sign, the name of the formula, in this case it would be average. Open the parentheses, highlight the data that you're interested in, close the parentheses, press enter. How about we put a little tag here Great. The max function calculates the highest or biggest number in a range or ranges of cells. In our example, to calculate the maximal value of all the cells in a range, we would find an empty cell, go lower here, D20, and type in the formula. Equal sign, the name of the formula, which is max, open the parentheses, highlight data, close the parentheses. 81. And that looks pretty good. 81 seems to be the highest number. The counterpart to max is min, which calculates the lowest or smallest number in a range or ranges of cell. Again, we would find an empty cell. In this case, we'll take D21. Equal sign, the name of the function, which is min, M-I-N, open the parentheses, highlight the data, close the parentheses, press enter. 7. And that seems right. Min. Note that the formula bar explains exactly what formula was used to create the result. Also notice that by double-clicking on a results cell, the highlighted field will be seen, as well as the coordinates used. Now, what if we wanted to visually illustrate our data? We would simply highlight the data, go to the Insert tab. There's a chart segment in the Insert tab ribbon. We will select the column chart since this lends itself well to categorical data, which is what this data set is. There we go. We have our first chart. Now let's try to modify it a little bit to make it more interesting. Notice that the tags are diagonal and somewhat difficult to read. You could solve this problem several ways. You could expand the chart to provide more real estate for the text. You could change your chart type to a bar chart, for example. You could right-click on the chart, go to Change Chart Type. We have lots of options here, but we'll check the bar chart option and press OK. You can see that this text is much more readable now, but we're not going to go with this option, so I'm going to press Ctrl-Z to undo. We can also change the tags themselves. So instead of Experiment 1, I'll put EXP1. Then I'll go back to my cell. I'll go to the bottom right corner. Notice that my cursor, which is a white cross, when I approach the bottom right corner, turns into a plus sign. When this happens, I can left click and drag all the way down. And Excel will autofill automatically. Now let's change the title and let's bold it. Back to the Home tab, bold. Let's remove the grid lines. We can click on any of the grid lines. You can see that they're all highlighted now, and we press delete. Let's also remove the outer border of this chart. To do so, right-click on the chart, Format Chart Area, and you'll see that there's a side panel that opens up. Under the Fill bucket, there are several categories. We're interested in borders. You can see that they're set at automatic. We will put no lines. And when we remove the highlighting from the chart, we notice that there are no more borders on this chart. We could change the color of the column charts by clicking on them. Clicking on any one of them will highlight the entire series. Again, under the bucket, this time we're interested in the fill category. We can select here and select a color that we want, or we can go to more colors where we can type in our RGB code or our hex code. I'm just going to pick a random color here, press OK. You can see the entire series is now changed. I'm going to press Ctrl-Z again, undo that. If I was interested in highlighting only a single element, I would click on that particular element. You can see now the entire series is no longer highlighted, only that element. And I could change that element's color, like so. Again, I'm going to undo that. So this is a pretty decent chart. We could be done here, but let's try to optimize it a little bit more. We'll move this one down here for now. Let's copy and paste our data here and start again. Notice I used the keyboard shortcuts this time to copy and paste. I could have gone to the clipboard area of the Home tab and done the exact same thing using those buttons. As I alluded to earlier, our data is categorical, and categorical data can either be nominal or ordinal. Basically, it can either have an order built into it or not. Now, while it looks like there's an order from 1 to 10, there really isn't. Experiment 10 is not any bigger than experiment 1, and experiment 2 is not any smaller than experiment 9, for example. So in this case, we're dealing with nominal data. And because it's nominal data, order doesn't really matter. So let's give it order in terms of size of results. To do so, highlight the data, click on the Sort and Filter button, and let's go to Custom Sort. We'll sort by column L, which is where the numerical data lies, and we'll want it from largest to smallest. In other words, in descending order. Press OK, and now we have 81 all the way down to 7. Okay, let's layer on more pertinent information. Earlier, we ran a few statistics on our data, so why don't we use some of that information for our chart? Let's go to M5, press equal, get the mean data of the entire set. 35, great. If we wanted to make this a series, we'd need to have 35 all the way down to the end of the series. But if we go back and click and drag down, that information doesn't really get picked up. That's because we're dealing with a relative reference, which is the default in Excel. The cell reference travels in the same direction that we create. Notice we have 35, 81, 7, and then a whole bunch of zeros. We need a way to lock in that information. We need an absolute cell reference. In order to do that, let's delete this. Let's go back to our 35. Let's go back to our cell reference here. We can put a number sign here. This will lock in the column element, so it's always going to be L. And if we put in a number sign in front of 19, this will lock in the row element, so it's always going to be 19. Alternatively, you could use the F4 key to toggle between these elements. In this case, only the row element is locked in. Only the column element is locked in. No elements are locked in, and all elements are locked in. This is what I want, so I'm going to press Enter. So if all the elements are locked in, it's always going to return the cell reference in that cell. Click and drag now, always going to return 35. Great. Now that we have two series, let's tag them appropriately. We'll call this one results, and we'll call this one mean. Okay, now that we have new data, let's create another chart. We'll highlight, just like we did before, Insert tab, column chart. Okay, there's a few things to note here. Notice that there's a legend that has been created since there are now two data series and they've taken on the names of our tags. You also undoubtedly notice that the chart looks a little bit weird. So let's make a few changes. Let's highlight the data referring to the mean by clicking on any item in the orange series. You'll notice that the entire data series has been highlighted. Let's right-click on it, press Change Series Chart Type. We'll go to the mean area, and instead of clustered column, we'll put a line chart. Press OK. Now I think this looks much better, but I'm not a big fan of how prominent the mean line is. So let's change that. If we click on that line, you can see that it's highlighted. And on the side panel, we have the color associated with that line. I'm going to change that to black. I'm going to change the width of the line to 1.25, so it will be thinner. And I'm going to change the dash type to this dash type. Great. While we're at it, let's just remove the grid lines because I think they're kind of a distracting element at this point. Let's put in a new title. Let's bold that. Go back to home, press bold. And if we wanted to drive the point home using color, we could do something like this. First, we would gray this out. Then those four experiments that are above the average, we would highlight using color. That looks pretty good. Let's add a few finishing touches here. Let's right-click on the bars, go to Add Data Labels. Terrific. Now let's click on the data label themselves. Now we can go Format Data Labels. On the right panel, let's check Inside End. You can see that the numbers show up well against the gray background, but less well against the blue background. For those, single click, change the text to white so that it has a higher contrast. I'm going to add another data label for the mean. You'll notice that the entire data series is highlighted, but I just want the very end data point. So I'm going to click on it, right click, add a data label, a single data label on that line. Finally, I'm going to go back to my chart, and just like I did to the other one, I'm going to remove the outside border. All right, the visualization is almost done. Now comes personal preferences. I take a more minimalistic approach to my data vizzes, so I'm going to remove a few elements that you may not want to, which is fine. I'm going to remove the legend because I don't think it serves a very good purpose at this point. And I'm also going to remove the y-axis because that information is now embedded in the column charts themselves. These are choices that you may not make, and that is fine. So hopefully you can see how visualizing the data can be helpful and that there are different degrees of visualization that can represent the data more and more insightfully. Okay, that's probably a good spot to stop for now. I hope that this was helpful and that you've gained some knowledge and confidence to explore Excel on your own. Thanks for watching, and I'll see you in the next video. Bye for now.